Welcome back to the Explainer. Today, we're jumping straight into the deep end of the software world. We're going to completely demystify the very heart of object-oriented programming, or OOP for short. We'll be breaking down those absolutely foundational concepts you hear all the time, classes and objects. We're going to get into the technical details, sure, but we'll anchor it all with some really intuitive, real-world analogies. So let's just get right into it. Think about the sheer chaos of the real world for a second. If you're building a massive e-commerce platform, a banking app, or a sprawling video game, you're dealing with billions of interactions and completely unpredictable variables. So how do we take all that noise, all that physical complexity, and translate it into structured, organized, and bug-free code inside a computer? Honestly, this is the exact puzzle software architects obsessed over for years. Well, that's exactly where object-oriented programming comes in to save the day. See, OOP doesn't just look at code as a boring, sequential list of instructions flowing from top to bottom. Instead, it's this incredibly brilliant paradigm that models your software around real-world interacting entities. We call these entities objects. The genius here is that you're bundling the data and the specific actions that modify that data tightly together. Let's break this down with a classic analogy that just perfectly nails these technical concepts. Imagine a car factory. On one side, you have the class. You can think of the class as literally just the engineering blueprint drawn on a piece of paper. It's the master plan. You obviously can't hop into a piece of paper and drive to the store, right? On the other side, you have the object. The object is the physical, heavy, drivable car that actually rolls off the assembly line. There's this fantastic quote from the source material that sums it up beautifully. A class is a template, while an object is the actual instance. This right here is the absolute superpower of OOP. You only have to do the hard work of writing that complex blueprint, the class, one single time. But once your program is actually running, you can stamp out thousands or even millions of physical realities from that one template. So, if we're coding this car, what does its anatomy actually look like? It basically boils down to two things. First, you've got attributes. This is the car's data, its brand, its model, its color, basically the nouns and adjectives. Second, you have methods. These are the active behaviors like starting the engine, hitting the gas, or slamming on the brakes. These are the verbs. Attributes are what the object is, and methods are what the object can do. Before we get our hands dirty with the code, we really need to ask, why is this so much better than the old-school procedural way of doing things? Well, in procedural programming, your data and your functions are just sort of floating around separately. For tiny script, fine, but scale that up, and you get an absolute nightmare of spaghetti code. OOP fixes this by locking the data and the methods safely inside the object itself. It makes scaling up incredibly clean and manageable. All right, enough theory. How do we actually build this in a modern language like Python? It's really just a simple three-step roadmap. Step 1, you define the template using the class keyword. Step 2, you set up those foundational attributes using a very special built-in function. And step 3, you produce the actual living object by simply calling that class. It really is that straightforward. Now, to make that jump from a theoretical blueprint to actual breathing code running in your computer's memory, Python gives us two pieces of pure magic. These are essentially the heartbeat of object-oriented programming in Python, so let's look a little closer at how they work together. First up is the init method that's init surrounded by double underscores. We call this the constructor. You can picture this as a hyper-efficient factory worker. The exact millisecond a new car rolls onto the assembly line, this worker jumps in and automatically registers its starting values, brand, model, color, into the system. You don't even have to ask it to run. It just happens automatically to give the object its lifeblood. And that brings us to the famous self keyword. Picture this. You're manufacturing a bright red Ferrari and a blue Ford at the exact same time from the exact same class template. How on earth does a computer know which car gets the red paint? Well, self is the answer. It points directly to the specific current object being processed at that exact millisecond. It's essentially the object raising its hand and saying, hey, I'm talking about my color and my brand. Okay, let's step out of the car factory for a minute and look at something we literally interact with every single day, an e-commerce platform. By modeling a basic product system for an online store, we can actually see how classes, objects, attributes, and methods all melt together into one perfectly functioning system. So in our product class, we start by laying down the core identity, the name, and the price. These are our attributes. But here's where it gets cool. We then inject a powerful behavior into this template, an apply discount method. Suddenly, our lifeless blueprint becomes smart. It actually knows how to mathematically calculate a discount on its own price, completely autonomously. Here is the absolute kicker. We write that product class code exactly once. Just once. But from that single template, we can instantly spawn two totally different, independent objects. Object 1 could be a massive $2,000 gaming laptop. Object 2 might be a $10 plastic mouse. In the background, they share the exact same genetic code from the product class, but in reality, they are completely separate entities. This hits on what is arguably the golden rule of OOP. Every object carries its own values. Think about it. Because of how objects encapsulate their data, if you apply a 20% discount to that gaming laptop, the price of the mouse doesn't budge one bit. Every single object gets its own private space in memory, completely isolated, fiercely protecting its own data. As we wrap up today's explainer, I really want you to lock this idea in your mind. You write that clean, elegant class architecture maybe just once in a project. But that one piece of structured intelligence empowers you to spawn an infinite number of dynamic, living objects that breathe and interact across your entire application. This right here is the true architectural secret to how apps with millions of users run flawlessly without instantly crashing. I'm going to leave you with a quick challenge to flex those new OOP muscles. Just look around the room you're sitting in right now. How would you model the coffee mug on your desk or the chair you're sitting in as Python classes and objects? Like a mug would have a capacity attribute and maybe a fill method, right? Try doing this mental exercise today. You'll quickly realize that code isn't just on a screen, it's the blueprint for everything around us. Keep building, and I'll see you in the next explainer.